So let's say I have, in general form, an equation of a straight line, okay? And I want to find the x-intercept and the y-intercept. So for x-intercept, I sub y equals to 0, and I get the x-intercept is 3. Likewise, when I put x equals 0, and I find y, then you can find the y-intercept of the line is 2. Now, I could actually rewrite this equation in what we call the intercept form, okay? This would be x over something plus y over something always equals to 1. And we will just fill out this number as 3 and this 2. 3 being the x-intercept and y being the y-intercept. So this is already the format, okay? This is it. And I could actually rewrite this back into the general form. And this is a good shortcut to come up with an equation when the problems are given the x-intercepts and y-intercepts. It actually saves you some time, okay? But if you don't remember this intercept form, you could still come up with the equation because you have y-intercept as these coordinates and the x-intercepts. You have these coordinates. And you could still use our traditional method to get the equation. So let's take a look at this example. So I have a line L1, x-intercept at A, y-intercept at B. I have another point C, so that A is the midpoint of OC and B is the midpoint of OD. Alright, so part A, we want to find the coordinates of C and D. Of course, we need to find A and B, okay? And we just need to find the x and y-intercepts, that's it. So individually, I put y equals to 0 here to get the x-intercepts, and x equals to 0 here to get the y-intercepts. This equals to -2, 0, and this would be 0, -3. And then because they're midpoint, then we could find OC and OD, and so C would be -4, 0, and D would be 0, -6. This one is easy. So part B, we connect C with D and we form another straight line called L2, and we want to find that equation. Of course, from what we've learned from previous sections, okay, that's easy, okay, using the traditional way. But now we could use a shortcut, right? And it's to use the intercept form. So x over something plus y over something must equals to 1, and we just fill in the x-intercepts here and the y-intercept here, okay? This must be a plus, right? So you fill the number, and after you find the common denominator and simplification, you get this answer for your general form. Now, before we move on, let's take a look at this equation, okay? Here's some very, very important shortcuts when we talk about general form. So let's say if I want to find the x-intercept, okay, I put y equals to 0, and then I get x equals to this, right? And when I want to find the y-intercept, I put x equals 0, and I find y equals to this. Now, as you can tell from the color, you could actually find the x and y intercepts directly by just looking at the general form. So when you have a general form like this, with A being the coefficient of x, and B being the coefficient of y, and C be the constant, and one side must be 0, then you can tell that the x-intercept is negative of C over the coefficient of x. Likewise, the y-intercept would be negative of C over the coefficient of y. So whenever you have a general form, you could immediately find the x and y-intercept using this shortcut, so you don't need to do the substitution and find the numbers. So let's put these aside here. We'll come back to this later and move on with part 2. And we want to check whether L1 and L2 are parallel. So obviously we need to find the slopes. y1 minus y2 over x1 over x2. And for L2, y1 minus y2 over x1 minus x2. Okay, so because the slopes are the same and therefore they're parallel to each other. Done. Now if you look at the general form, you can tell that the 3 actually comes from coefficient of x, and 2 actually comes from coefficient of y. And that also is another shortcut that saves you a lot of time. And so the slope equals to negative a over b. And along with these two shortcuts, okay, these three are all you need to know for the general form.